Do you ever wonder that all those sparkly things in the night sky aren't anything but stars like our sun? Are they all the same or do they have variants? Today, I will explain everything about those stars and their variants. Many people will tell you that there are many kinds of stars, but there are only 3 main star variants, and every other star is actually a part of those 3. These 3 variants are red dwarfs, main sequence stars, and blue giants, when a star just starts to form but is not fully formed yet. But due to the intense pressure, it warms up and starts to glow. We call it a protostar. Every star has to go through this phase to become an actual star. Then come the red dwarfs. These stars are actually very small compared to other stars. A red dwarf has a mass of only 0.8 to 0.6 times that of the Sun, and their surface temperature is only 2500 Kelvin. Because these stars are really small and don't use their fusion core that much, they live for a very long time. Scientists believe that a red dwarf can live for up to trillions of years, and our universe is only 13.8 billion years old. A red dwarf will not die with an explosion and something like that. Rather, it will die slowly. When its fusion core ends, it will just stop glowing and become a white dwarf. We'll talk about white dwarfs later. Now let's talk about main sequence stars. Our Sun is a main sequence star. These stars are the average size of stars, and they are actually kind of orange. A main sequence star can be up to 200 times more massive than our Sun, and its surface temperature is 3000 Kelvin. A main sequence star dies very dramatically. When their fusion core ends, these stars start to grow bigger and bigger. As for our Sun, when it dies, it will easily consume our Earth into it. Then it will become a white dwarf. Now a white dwarf can become a neutron star depending on its size. An Indian scientist named Subramanian Chandrasekhar calculated the mass of a white dwarf and concluded that if a white dwarf star has a greater mass than 2.765 times 10 powered 30 kilograms, then it will become a neutron star. We call this limit the Chandrasekhar limit. So when a white dwarf star surpasses the Chandrasekhar limit, it will become a neutron star. And when a neutron star releases electromagnetic radiation from its poles, we call this a pulsar. So that's the main sequence star. Now let's talk about giants. My personal favorite, blue giants. These stars are really massive. They can be 1700 times bigger than our Sun. UY Scuddy can fit 5 billion suns in it. Its surface temperature can be around 5000 Kelvin. When a giant's fusion core ends, the gravity is so intense that it will curve into space and time. Then it will burst. We call this event a supernova. A supernova is so powerful that it will produce more energy in a single second than a sun needs 10 billion years to make. After the supernova there will remain a core, a black dense core. We call this a black hole. So that's it. But there are some more things you might need to know. Scientists classify these stars into 7 categories named M, K, G, F, A, B, O. K and M categories are dwarf stars. F and G are the main sequence stars, and our Sun is a G category star, O, B, and are massive giants. So that's it for today's video. I hope you guys learned something new today. I will see you in the next video. Until then, goodbye.